Hey everybody, welcome to another PowerShell Wednesday, and in this session we have a Dev Containers deep dive with Justin Grote. Justin, what are you going to be talking about today?
Yeah, so today I'm going to be talking about building containers and using PowerShell inside those containers, as well as using containers as a way to do development, being able to use things like GitHub code spaces, using dev containers on your local machine, using things like Docker and Podman to be able to write and develop scripts and PowerShell modules and anything you want inside an isolated environment that doesn't affect your system. So if you blow something up, you don't blow up your system.
Awesome, and I hear there's a little teaser for another module you've been working on that uses code spaces.
There is. I will be showing off a module that I built entirely using code spaces.
Awesome, well let's get into it.
And so they've pretty much decided that, hey, the .NET team is building the .NET SDK, which includes PowerShell. And so primarily just going to be using that for the images that they will quote unquote support. Now, the PowerShell Docker images have never been meant for production. They've never been stated that way. They've never been ever mentioned for anything but development purposes. But this is just sort of a decision that's been made to enable that aspect so that people can use .NET SDK as their primary development image for PowerShell. So this has a couple implications, one of which is that there really isn't any kind of developed image for Docker images that is more for like the runtime aspect where you just want to run PowerShell either in production or otherwise. And it also means that it's a little more difficult to figure out, like if you want to pin for a very specific PowerShell version, like you want to make sure you're running 7.4.2, or you want to know when the latest version is available. There's some difficulty in there. So I have a solution for that, which I'll get into, but I'm just going to back up for just a second and talk just a little bit quickly about what Docker is and what containers are for anybody who hasn't, everybody's probably at this point heard the term, but maybe are just not aware of what they really are. So I'm going to talk a little bit about those here. So I have a couple diagrams here that are real quick. What a container is, effectively, is that if you're familiar with a virtual machine where you have a server or your computer, your personal computer, there's a special little layer that gets inserted called a hypervisor. And that hypervisor abstracts stuff away from the computer in the same way that the operating system abstracts stuff away from the hardware, so that you can have these virtual machines. You can have these little individual operating systems. And this was a game changer when it came out, has it been like 10, 15 years now when it really got popularized, really made it so that we can be really dense about how things operate. But you still have all this guest operating system cruft and such like that. So what a container does is that it takes just one of these guest operating systems and makes it a platform for running these containers. And what a container is rather than having all the guest operating system scaffolding, it's just enough to be able to run an application. So you're sharing the same operating system at this point, but it's using technologies such as chroot and other things that basically allow it to isolate that application in such a way that it still looks to the application like it's a separate operating system, but really it's just got its own little jail. And so the nice thing about that is that we're able to spin up many, many more of these with a lot less overhead. We don't have all the guest operating stuff and all the drivers and all that kind of stuff. They can be spun up and torn down and built out. And this is sort of the foundation for all of this sort of infrastructure ideas of like cattle, not pets and whatnot, that lets you be able to build these applications that are so self-contained that you don't have to worry about all the dependencies and getting things set up and all that kind of stuff, but also that you can have these applications that run. And if something goes wrong in them, just destroy them and recreate them, because we can do that so fast. And we can design them in such a way that they don't have to carry a lot of state. So the way that Docker makes that work is that it has that host image, which this is either just a physical server or a virtual machine or something in between. WSL counts. So if you have WSL on Linux, if you're using Docker on Windows, you're actually using Docker running in WSL, and that's where your containers end up living. But you have these steps for building containers. These containers use these things called images and image layers, which is a really clever way of making it so that in the way that you build containers and build the files, you just have these layers stacked one on top of each other, which makes it really easy to just push in new changes without really needing to know anything about the file system or even having different file systems. It's just a way to do that layering for all you need to know for right now. And so those images are ways that you can push different types of containers that then become the actual containers that do the work. And those containers can be stored in various kinds of registries, which include Docker Hub is the most popular. Microsoft runs their own registry called the Microsoft Container Registry. If you have a GitHub account, you can run your own container registry for free using GitHub packages, also known as the GitHub Container Registry. Lots of different places you can run these things. So that's just sort of an overview of what those images are and what Docker containers are. So what I'm going to show today are sort of two separate things. I'm going to show the concept of dev containers, which now that we know what containers are and we have this ability to put things into a container, we can also now use that to package our development requirements. So when you have to go to contribute to a software project, you can have everything batteries included in this self-contained environment without you having to figure out how to install .NET. And maybe you've got the wrong .NET version installed, and maybe it's got some special utility that requires pre-compilation or any of that kind of stuff. And if you've ever worked in open source software, a lot of times you'll see a README, and the README might be out of date, and it can be really frustrating just to get started. Whereas dev containers give you the ability to just get up and go and have this isolated environment that you can just start doing your development in. So if you are watching this either live or recorded, the nice thing about containers is that there's this service provided by GitHub called GitHub Codespaces. So with GitHub Codespaces, what we can do is we can run containers for free. What I'm going to show you is totally free, and you'll be able to do this along with me. So get your fingers, get your keyboard ready. You'll be able to go to this repository, github.com/power Justin Grote /PowerShell-containers. And I'll take this and put it in the Discord for a link real quick. So you can go ahead and follow that link. And when you get to this repository, you should see this GitHub page. And so there's two different things you can do here. You can click code. Basically, you'll just be able to click create code space on main. Or if you're just in your browser, typically you can also just hit the comma key on your keyboard, not the period key. You may have heard about the period to launch VS Code on the web. That's a different thing. Don't worry about the differences right now. But for now, you're going to want to use comma instead of period. So in this case, I'm going to hit comma. And you're going to get this nice dialog to create a code space. You can change some of the options on it, like if you want to have more container cores or whatnot. And you're going to use this special thing called a dev container configuration. So I've already set up a special dev container that basically will build the container for you and get you into this environment. So you can go ahead and click create code space at this point. And if you have VS Code installed, this is actually going to open VS Code and do it inside of VS Code. I disabled a certain setting you can do in GitHub to make it so it always runs in the browser. But in this case, you're going to see it open in my browser. And this browser, what's going to happen is that it's going to start up a little container on the GitHub infrastructure that has all of my prerequisites and everything pre-built. And you see it goes ahead and opens up the README and everything. And so you'll see here, I have a terminal. In fact, I have a terminal that has PowerShell in it. But what this has done is that you're now running inside a container. And so this may not look like it, but this is a VS Code that is attached to a container on the back end. What you have now is you have this sort of isolated development environment. Here's my PowerShell, just a git child item and all that stuff just to prove it. And so you notice like now I have this environment that acts like a virtual machine and has things like the terminal, which you don't get in the VS Code for web and that kind of thing. And you have all the aspect here. You have that. You have the PowerShell. I don't think I told this to install the PowerShell extension. Oh, I did. Okay. So you have all your PowerShell IntelliSense and everything. This all works as expected. So if you have a project that is PowerShell driven, you can have all your modules pre-installed and whatever prerequisites you have and any tools like Platypus or whatever for building, you can have all of that pre-installed and ready to go. So that's a quick way of just showing what a dev container is. As just an idea, just this concept of you now have this place that you can develop and do work in. So the way a dev container is defined is there's a special file called a devcontainer.json file that you put in your repository. And in here, you go ahead and you define some stuff. So at the very base level, it's really just these two things that you need. You just need just a name for what you want to have it. And that name is what shows up down here. And then you have an image, and then this is the image that you want to pull from. So in my case, we talked about that there's now these new .NET SDK containers. And those .NET SDK containers also have something built on top of them for the Microsoft Dev containers. If we go to mcr.microsoft.com, which is the registry for this, we'll see here .NET container images. So these are images that are published by the .NET team. And these images are basically container images that they built that contain a version of .NET SDK, which is great if you're building binary modules, which I do a lot of. It also contains the latest version of PowerShell as of the date that the package was published. And they have a lot of different variations. Most of these are based on the Debian or Ubuntu Linux distributions. And so Noble is a Debian variant. Noble is the Debian variant. And then you have Bookworm, which is another Debian variant. Jammy is the Ubuntu variant. You have all those aspects that you have here for these different images that you have. And these numbers here are the version of .NET you get. So .NET 8, .NET 9, .NET 10, etc. But these images all come with more or less the latest version of PowerShell installed. And if the image is there, then what you can do is, so in your dev container, to find out in your image, which get back to my dev container here, so I do PS version table, and you'll see it there at the top. it has 7.5.0. Now, it doesn't have 7.5.1 yet because the .NET team has not built a newer SDK for that. So that's kind of one of the issues I want to illustrate, is that these dev containers exist. They're there for SDKs. They're great for development. But what if you need the latest version of PowerShell, or you need to pin to them? Well, there's this really nice feature for dev containers called features. So you can add in this thing called features, and then there's a bunch of different features you can add, where this basically just falls into, there's a whole list here, but these are basically just glorified shell scripts that'll automatically install different versions of tools that you need without you having to do it in custom scripts like I had here with this initialization command and a post create command. So my post create command installs all the Docker tools that I need, all my extensions and that kind of thing. But if you don't want to learn any of that, you can just go here to the features and look for PowerShell. And then you can go ahead and do the version that you want for that. And then you have the ability to specify like the latest version, that kind of thing. You can learn more about those features. I'm just going over these real quick because this is not the main point of this presentation, but this just kind of gives you the idea. And it'll show you the features, and then you can go here to learn more about this for installing these additional features. So these are just quick ways to have a base level container. So you can use the .NET Dev containers. You can use anything you want. You can use an Alpine Slim image if you really want to start light. There's a lot of dev containers for Python and PowerShell, et cetera, that already exist. So these can be used for pretty much anything. But for this example, we're just using the .NET Dev container because it comes with a lot of stuff already pre-built in that we want. But then you can tune and tweak and customize them as you need, so that when people are coming to use your environment or use your dev container, then they have their whole environment set up to go. So in this environment, I've already updated the software. I've installed additional tools I need, like Podman and Scopio, which I'll talk about here in a minute. I've added a special container env because of something weird that happens with the newer version. Already somebody who's contributing to my repository doesn't have to know about that. I've already fixed it for them. And I've already pre-installed a couple extensions that are going to be useful to somebody. So the PowerShell extension, this VS Code-containers extension, this is actually a new extension from Microsoft. This replaces the Docker extension. So if you're currently using the Docker extension, you're going to want to uninstall that and start using this. And the thing about this is that the nice thing about this extension is that it's now called Container Tools. It still looks the same as the Docker extension, but it now has the ability to operate with multiple different platforms. So Docker is the most popular one, but there's a lot of up-and-coming platforms using the Open Container Initiative, which is this, let me show you real quick. This is sort of like the open standard. So Docker was sort of like one of the first people to really do containers, but there's now the Open Container Initiative, which lets you define sort of a standard for containers. This is like the TCP/IP of containers. It's just the open standard that everybody is sort of moving towards and using. Very famously, there was this announcement in Kubernetes that they would stop supporting Docker, and then everybody freaked out. But really what that meant was just simply that they're just moving to do this OCI style image, which is the way that the images are built and a specification on the layers, and that they're just supporting those. But you can still use Docker and other tools to build those images. So can containers be stored on GitHub or server share? Yes, I will get to that in a bit, so hang on. So once you have a container definition, I'm showing dev containers here for, you can use a container, get that, and have your dev container there. Dev containers don't only have to run in GitHub. So for instance, I just want to ask, has anybody on the Discord, go ahead and put in chat if you've been able to get into this dev container, hit comma, and be able to actually see this console and work with it, even though it's in your browser or in VS Code. Isn't that really neat? Like, this is something that anybody's ever seen in here, but you actually have like, a full access in terms of like a PowerShell, et cetera, in your web browser. And this works not just in, like I'm on Windows here, but this works on Mac, works on Linux, works on an iPad. Anywhere that you have a browser that can support the JavaScript required to run this thing, you can get this full dev environment. And it doesn't matter where you are. You can run on a Chromebook. So people who are in smaller countries don't have quite access to the money to build big fancy computers to run the compilers. You get 80 hours of GitHub code spaces for free every month as a GitHub user. And you get a little bit more with Pro. And then if you're doing private stuff with GitHub Enterprise, that has a per price thing, et cetera. But it's just a way of running these dev containers, is that GitHub provides this thing called code spaces, which is a very nice way of running containers. So I want to very clarify the difference between dev containers and code spaces. So dev container is the specification for how to make a container that has everything pre-built into it ready to go. And that's what basically this file is it defines that. Code spaces is one way to run those dev containers. It's a way that's hosted by GitHub, really easy, really transparent, et cetera. But you can also run these dev containers anywhere that you use any kind of container platform. So here locally on my computer, I use a platform called Podman. So there's the two sort of biggest container runtimes that exist today. The three are Docker, Podman, and Kubernetes. These are three places you can run containers. There's a lot of other ones. I'm sorry if I didn't mention your favorite, but these are the three that I'm most familiar with and have sort of the broadest support. So Podman is actually mostly sponsored by Red Hat. Podman's like the biggest backer into the development of, or Red Hat is the biggest backer of development into Podman. So if you've ever used Docker, the main difference between Docker and Podman is Docker requires sort of root access and it runs a daemon that coordinates all your containers and runs them. What Podman does is Podman is pretty much all in user space. So Podman runs just locally to your computer. And then the Podman agent and all that is just commands that interact with the Podman runtime. In this case, it's a virtual machine running in WSL, which I'll show here real quick. I just rebuilt this computer, so my prompts aren't up to date. But if I do a WSL, you'll see that there's this Podman WSL server running on my local machine. And this is what basically acts as that container runtime that I talked about before. That's the quote unquote virtual machine where all these containers are running in. So like I can do Podman ps-a, and these are the containers that are currently running on my system. If you don't like the command line as much, and you have these nice little GUI here for here's all the different containers I'm running on, they tend to get these cute adjective, noun, names that get generated. But you'll see I've got a couple different ones here. You have different ones that I've been generating for different purposes, and they're running, and I can use them. And then you have the base images, which are those images that I talked about that have these lower layers and those aspects that where it just layers on top of each other to end up creating this Docker image that I'm using. I know I'm glossing over like a two-day Docker class. That's on purpose because it's not important so much for what we're doing. So if you want to know more about any of this, there is a wealth of information out there about Docker, Podman, images, what are containers, what are pods, etc. I'm just sort of giving you the overview here to get an idea of what these sort of concepts are. So a question came up, can you have your local VS Code dev container run in Podman? Very astute of you. That's literally the next thing I'm going to do. So as I mentioned, Codespaces is the way that for GitHub, you can run containers in a hosted environment. But if you are doing a local development without even having a GitHub account, you can run dev containers locally. So in this case, let me go ahead and kill this out real quick. So I want to start from the beginning. All right, so I have here a blank VS Code. Just open it up, standard normal startup. And if you have one extension that you have to first install is this dev containers extension. So this dev containers extension has to be installed in order to get sort of this additional things. Once you have that installed, you have down here under open or remote, you get some of these new options. New dev container attached to an existing container, clone a repository into a container volume, or open a folder in a container. So these open up the ability for you to take any application that you have locally. If you just have a folder full of PowerShell scripts, you can just open it in a dev container and do that editing and working without impacting your local system. On Windows and Linux specifically, it has the ability to basically use your folder directly that you have. So if we look at, for instance, the PowerShell repository, it has the ability to make changes directly here. So whatever you're doing in the dev container edits those local files. Unfortunately, that mapping comes at a cost because of that mapping between Linux to Windows. That performance ends up being very slow. So while that is an option, if you're doing anything heavy that involves compilation or anything that's not very basic, that doesn't require a lot of file access, I generally recommend you do this other thing called opening in a named container or named volume. And what that does is that you end up getting this volume that in Docker is just sort of like, think of it almost like a mounted drive. It's just like an additional drive that gets created as a file on your file system, but then gets used like it's a virtual disk, like a VHD or a VHDX, but it's for containers. And so you have the ability to do that. That volume ends up being a place you can store things. So what it ends up doing is it's able to use that. You can see I have these containers that are using that drive and keeping that information in there. So the nice thing about that being is that because it's got that disk, it'll operate really, really fast. So there's a lot of preamble to just do what I was going to show you here. So I have that PowerShell containers thing that you're probably running in Codespaces. This is another way to open it locally. So I'm going to choose clone repository and container volume. I'm going to clone repository from GitHub. I'm going to choose my Justin Grote PowerShell-containers repository. I'm going to take the main branch. And I previously told it what volume I wanted it to open in, but at that point you would get a prompt to say, do you want to create a named volume or do you want to use an existing one? And so if you get a chance to create one, just create it, name it whatever you want, and it'll do it. And then this part starts where the dev container gets checked out, and you can see it's going through that build process. It's going to take a little longer than usual because Codespaces supports this thing called pre-builds, where it actually went through all these extra steps of downloading all the updates, installing them, doing all that stuff. It did all that stuff for me already in Codespaces, and that's why the Codespaces one just comes up immediately. This kind of stuff you can build into your dev container image as another Docker layer. That's outside the scope of what I'm going to talk about here, but just know that you can skip this step also locally by doing a pre-build as well. But pre-builds in Codespaces are super nice because they let you do this stuff without having to constantly manage it. So now I have a container, and so this looks like just, again, VS Code running on my desktop, just like any other VS Code you expect. But you'll see down here it shows dev container, PowerShell Runtime containers. And up here, I have a customized top bar, but you can see it is currently running in a container. And if I go to my Podman here and I refresh it on my containers, I now have this new Peaceful Alameda container that is running, 1 minute running. That's my dev container. So I just have this now isolated environment that has my container running in it. So this is my container. And as you see, it doesn't have my local disk file system. And in fact, if I do a PS version table, or is Linux, you'll see that it's running that version of Debian or Ubuntu, the dev container. So this is actually running in Linux, even though I'm on Windows. And as a result, it's also not touching my system. So I can completely screw up this container. I can RMRF the whole thing. And if it blows up, I can just do Control-Shift-P, rebuild container, and then I'm back to where I was. So as long as you're taking your checkpoints, you're doing your snapshots, you're committing your changes to VS Code, and because everything that's on the disk, this gets saved in that special named container, again, you can totally screw up the container. You can remove PowerShell accidentally, which PeterSH, rm user bin PeterSH, sudo. It's like, okay, now my PowerShell's all broken. Crap, I don't know what I did, but I did want to make this extra change here. Okay, well, this is all messed up. How do I fix it? Just say rebuild container, and it'll get me back to that nice basic place again. It'll reclone the repository, merge it with whatever I had locally. And you'll see I got my environment back. My PowerShell is working again. See, that's back. PowerShell works again. But that file that I changed is still there. So you can experiment with things, do things. And if they completely blow up your machine, you can test with sudo. You can do that kind of stuff. But you're not having to completely rebuild your computer if you screw it up. You can just reset the dev container. So it's great for these kind of things, and great for experimenting, and great for isolation. You can test out somebody's repository. And if you're worried that the repository has a virus or something, that when you run the build script, it takes over your computer, worst they do is take over this little isolated container you have that you can just destroy. So they're great for development, great for usage. You can advertise them in such a way that, this is sort of like a VDI to developers, so that this is what they get into, this is where they work, and this is the only place they work. And then if they have a laptop, they can just come in on their bring your own device laptop from home and not even need a work computer to do it, and still be in an isolated, controlled environment where you control the code, you control the back end, etc. Are there Windows containers in MCR? Yes, there are Windows containers. I'm not going to talk too much about the Windows containers. I'm not a fan of Windows containers. I'm not building PowerShell images for Windows containers, but they do exist. You can use them. They're very painful. If you can use Linux containers, do. And PowerShell runs on Linux, it's fine. In my opinion, the only time you should be using a Windows container is if you're trying to containerize like an IIS app or something that you can't move to web app, and you can't otherwise run it in some other format. They are useful for some very specific niche cases, but they have a lot of overhead. They're very painful. There's not really an ecosystem around them. I just recommend don't use Windows containers unless you absolutely have to, and plan to become an expert in Windows containers because you're going to be troubleshooting a lot. As far as the containers go here, I have my environment here, and yeah, again, as somebody mentioned, I can do git process, stop process, blow everything up. Now my container doesn't work. This thing doesn't work. And anytime, you can also just do reload window if your thing ever gets completely messed up, and that'll just reload the dev container as well. So this dev container is here locally, and so I have these. I can make my changes, I can push, I can do all that. And so we're going to go into some sort of examples of some containers. So in terms of building containers, the PowerShell team is no longer providing the runtime container aspect. I have the ability to now publish my own containers. So I'm publishing a version of PowerShell containers that these are used for running PowerShell. So this is, you've been seeing like the development side, and this is more for the publishing side, for the actual like running an actual production application or a script or whatever in PowerShell. So I built these containers that very simply allow you to run these containers. And if you have Docker installed, you can run this right now without anything locally installed. That will fetch my container from the GitHub container registry. That's what GHCR is. And then by default, whatever script you give to it as a string, it'll run. As you can see here, you have both of these. You can also configure it to run files. You can do all that kind of stuff. So we're going to play with that a little bit here inside of our dev container. So I have a couple examples here. So by default, at the console, you have both Docker and Podman, and they're going to look the same. However, I did something a little sneaky here, is that the Docker command is actually Podman. I think it should show here. Yeah, so you see Docker is actually alias to Podman. So Podman has been designed to have exact one-to-one compatibility with Docker for the most part. So if you're familiar with Docker PS, if you want to switch to Podman, it's really easy. If you're already familiar with Docker, you just do Podman PS. I do Docker PS-A, then I get Podman PS-A. And so you're able to switch backends a lot easier. But Podman is much better for development because it doesn't have that whole infrastructure of a Docker, it doesn't have the whole Docker service and the Docker pipe and all that kind of stuff. So Podman's compatible with tools that use Docker, but Podman just runs as a user space thing. And so it's much easier, much more flexible, much less cruft, much more secure because everything runs in user space. So you can run Podman without being root. And in fact, all my containers are built to be rootless so that you, when you run a container, it is as a user. So if I do, for instance, again, that Podman run ghcr.io Justin Grote PowerShell, this will go out, fetch the container, and the container is only 100 megs, so you'll notice it fetched it really fast. And oh, it's because I did that like that. And so you can see the container ran. I recently made a change that the containers start up much faster. They're a little bit bigger, but they start up really quick. So you'll see there in running a script, it was able to do it and run it and install it very quick. And so you see it has the latest version. If I wanted, for instance, I wanted 7.4, then I can use that tag, and you see I get the latest version of 7.4. If I want to pin to just whatever the long-term support version is, I can do that too, and I get whatever that is. If I want to pin to whatever the latest version is, I can do that too. And if I want to play with whatever preview releases are out, I can do that too, and I get that preview release. So containers already, as you can see, are a really fast way. Like, for instance, if you're running testing, you can test on every version of PowerShell that exists without having to install them and do different side things and that kind of thing. So question, can you run a GUI out of dev container? Yes, but. So dev containers support the X window framework. So if you want to like test a GUI or anything like that, Podman and Docker both have X forwarding. So doesn't work. It's a little tricky to get working on Windows, but you can do it using some of the WSL X compatibility stuff. If you do it on Linux or Mac, it works just fine. But yeah, so like if you wanted to test running a GUI app or building a job app or C# app and then having that pop up, it is possible. It requires you to do a bunch of stuff called X forwarding to make it work. It's not super simple, but it is possible. So you can do dev container work for GUIs and that kind of thing as necessary, but there are some restrictions and limitations to kind of work around. Typically with dev containers, you're using them for applications that are like microservices or web apps or things that you're going to publish to Kubernetes. That's sort of like the biggest one, is that if you're building containers, you're building a set of containers that all run as this orchestrated Kubernetes app. So I'm going to show you how to build a couple PowerShell-based containers, because you may be in an organization that's using containers. You have fellow developers that are building things in Python or C# or Rust or whatever, and they're building all these applications that run and like fetch something from an API and do something else for that. Well, you don't have to be let out of that. You don't have to be let out of that crowd. You can build applications using containers, ship them off to Kubernetes, have them run PowerShell that you're used to, and be able to maintain and support them in that same ecosystem. Have them be restartable, have them do everything that any other container can do, a PowerShell container can do. So in this example, I just have a very simple script. This is an example of building one that contains a script. So I already showed an example of running a command line script. You can do the PS version table, you can do calsay, you can do, get random, anything you can run as a script, you can do that. But typically, if you're building a container, you're going to want to actually build it as an image. So to build it as an image, you always start with this thing called a Docker file. Now, you don't technically have to start with this. There are other ways to build a container, but you're going to find the most documentation on how to build a container using a Docker file. So we're going to show that example here. So in this example, you start from a base image that you want to use. And so in this case, I'm doing the ghcr.io Justin Grote PowerShell, my base image. I'm going to add in the script that I have here in the folder. So this statement just says, hey, take the file that's in the same folder, which is, again, a very simple script here, and go ahead and add it to my thing. and then set the command, which is basically set the entry point to use this script. And this README sort of explains more info about what that looks like. If you're coming back to this later, you want to see this README sort of explains what we're doing. So we're in this folder. We're going to go to examples. We're going to go to the script, and we're going to go ahead and just do docker build -t ps hello. The -t is basically assigning it a tag. So you saw like with my image, like my containers have like latest LTS 74742. Those are just tags that identify. It's a way of labeling the thing. They're just like Git tags. You know, Git has a commit ID, but those commit IDs are long, ugly strings that are hard to remember. A tag is just a friendly name to reference that commit. So if I do that, and I always need to do a dot there. So here it's going to take those 3 steps. First, it's going to go fetch my container, which I already have locally cached. So that part went really fast. It's going to add my image, and you see it added in this number. So this is where that layering things come in. So I have my base image, and now it's going to add in that extra little layer of that image, and then that layer now gets saved as part of that image. And so now when it has to go to install it, it doesn't have to repeat the process of like, say you were like running an MSI install or you were unzipping a file. It doesn't have to go through the process of doing that and doing all that customization, all that CPU intensive stuff. It now just basically has a snapshot of what it's supposed to look like after that step, and it can just apply the bits to that same layer. And that's part of the power of Docker containers, is you can make little changes and have those incremental changes be the only thing that has to be downloaded, as opposed to having to download a whole virtual machine again. If you work in any kind of VDI or virtual machines, you know, whenever you rebuild a golden image, you have to push all that stuff out, and it's a big pain in the butt. This is one area where containers massively simplify those headaches. So now, I also just want to show that Podman, I could have done the same thing, because this literally was just Podman under the hood doing it. So now if I look at my Podman image ls, I now have this local image that I've built. And so it's a base image. It's only 172 megabytes. I build these images in such a way that they're built in an extremely stripped down way that's basically just PowerShell and nothing else. So they're very secure, very fast, low footprint, as opposed to like the .NET SDK containers, like 2 gigs in size. But these are really nice, lightweight, and very secure because they're only contain the bits to run your script, as well as whatever else you choose to add in there. So now I can do my podman run ps hello, and you'll see my script will run, and it just runs this script that I made. And so you can have parameters come in as different names and arguments and such like that, and those parameters can be supplied as part of your run instructions. So if I do this, you'll see that it substituted friend for where I had name in the script. So you can see not only can you make containers, you can make really cool parameterized containers that you can make for one purpose and do otherwise. So we're going to show an example of that, but also one that includes a PowerShell module. So I have here an example of a script that has a module built into it. Now, my containers, if you build other containers, that's fine. My containers don't include any package managers or anything like that. So I've stripped out PS resource Git. I've stripped out everything because the only things in that container are what are required to run your PowerShell script. That makes it more secure because somebody can't hijack your script to go and run something else or run something inside the container unless you make sure you specify that as part of the script. So as part of my build script with the modules, I'm going to do more or less the same thing. We have the same start here. We have a main that's going to add a script here. This is a script using my IP network module, which is used for IP and subnet calculation. And so we have a very simple script here that you can have a container that you input to it the IP you want, and it outputs you the network ID. So this is a simple example, but you can translate this even further. Think of something that inputs a REST request and outputs a result, something that takes in some ticket information and writes it to the ticket system, or takes in input from a user, or you have a whole GUI that you have for creating a user. When you hit submit, it goes to this container, which then goes to the backend and creates it. But you have it in this nice containerized environment rather than trying to run it on a virtual machine or trying to run an Azure automation or any of those kind of things. You have this stable environment where none of the dependencies or anything change. So you're able to run it exactly how you want it with exactly your PowerShell version and make that really stable and reliable and useful. So we're going to run this script, but to run this script, we need a module. We need this IP network module. So in my Docker script, we're going to do a thing where we're just going to add this little thing in here for a shell to tell it we're going to use that. And then I'm going to do a run step that's going to run a script. And this designation is just a way to say anything. Doing this statement is just a way to say Anything that comes after this is verbatim. None of this is part of a Docker file. This is all what I want the script to be. Until you see a new line with this same word, pretend that this is all verbatim. This is like here strings in PowerShell. Like if you do, at quote, all this random stuff, and then you do a quote at the end, it's basically tells PowerShell ignore all this stuff. This is like here string, but for a Docker file. So what I'm going to do is I'm going to use ModuleFast, which is my tool for rapidly installing modules, to do this installation. So ModuleFast has a way to be quickly fetched and initialized. This is basically a way that goes out and grabs the latest version of ModuleFast and initializes it. And then I'm telling it to install ModuleFast using the script. And so ModuleFast has an ability that if you go to this script, because it has the requires specified in the script, ModuleFast will install the modules that are required for that script. So I don't even have to specify it. I just maintain my dependency versioning in the script, and ModuleFast will keep it up to date. So if I want to specify a particular version, that kind of thing, I can do that. And so it will go ahead and just install the requirement for that. And now that module that's required to run this script will be in the right place. So let's go ahead and build that guy. And I see that there's some pending questions. Let me just get through this and then we'll get to those. So we're going to go ahead and follow my little README instructions for this one as well. We're going to call this one PS Network Finder. And again, you can name them anything you want. We're going to call this PS Wednesdays just to show that. I have to always do the dot. I always forget that. Oh, I forgot I stripped down these containers. So I think this one actually does require Docker to build. So I may have messed that up because I haven't fixed this one for Podman. Anyways, what this one will normally do is it will go ahead and build the container and then have that available. And I can fix this. I just don't have time to do it right now. But when you do the run, then we have a built version that has our module in it. And so when you run, like, for instance, the default script just had like an example here. It will run my little script here, which will be get network IP and then get the network address off of it. And you'll see the IP15 is .0. And if I can also give it a parameter like I showed before, where I do like a /8 on this network, and then I get the actual network name using that. So there's just like a simple example, but you can also use things like Pod and PowerShell Universal to build full-fledged web apps that when you start this container, you can hit it on an address and be able to interact with it and have a user creation app, have a script that does stuff in Graph, have a script that does things in Azure. So that's the general view of what both dev containers and PowerShell runtime containers, which are a form of container you can use to run, are different ways you can use containers to both develop and run applications. And you don't have to be in a world where you know Kubernetes and all that kind of stuff. You can get there, but you can start by simply building your applications in containers. So I'm going to show one last thing, an example of an application I have built entirely in a dev container. So I have this application that I've been working on called ExcelFast. So I'm going to go ahead and open this with code. And I should already have a running container here for it, or if I don't, we'll go ahead and reopen it in the container so it knows that it's there. And so in here, I have a dev container that from day one when I built this, I knew I was going to be making a binary module. And this is a module that was going to use C# and was going to use PowerShell, was going to use a few things. So I have a dev container here called ExcelFast. I know I was going to build it for .NET 8 because I wanted to be compatible with all LTS versions of PowerShell. So I specified .NET 9 here just so I have it and have that pinned. I know the extensions that I want. I want PowerShell. I want my pester test extension. I need C#. I want to be able to do pull requests. And I have a fancier version of the GitHub Actions extension that I wanted in this container. So I had that too. And then post create command, I wanted to go ahead and do a .NET restore so that everything's up to date and ready to go. So there I started it up. Here's my dev container. We're in here. This one's out of date. I didn't do this in the named volume. I meant to do that. Repository named container volume. So this is an example actually of where this is actually tied to my local file system because I didn't tell it to use a named volume. So if I do a new item test 5. If you go to my folder here, you'll see test 5 shows up on my local file system. So that's really convenient if you're doing something that's not really write heavy because you share the same folder between your local computer and the dev container. But for the stuff that I'm doing here, doing compilation and stuff, it's usually better to have it in a named volume. So I'm going to go ahead and just do that named volume thing again. Oops, that was not the one that I wanted. And here's that step that I mentioned where like it'll ask you, do you want to create a new volume or do you want to use existing one? I'm just going to use my existing one. So Excel Fast is a module I've been working on to make importing and exporting Excel files really, really fast. And so to do that, I wanted to build it in this dev container. And so part of it is that if you wanted to ever look at how this works or build it yourself, you can go to this repository right now, Justin Grote /ExcelFast, and hit comma in the same way I did comma and get this exact environment that you see in front of you, that even though I have it running locally on my machine to take advantage of the memory and stuff that I have, you would see all of this in the exact same way I do, with the exception of all my customizations, where you would see your customizations. If you still have this over on the left and this stuff, over here, you'd see it how you see it. So all that stuff stays with you. But as far as the environment in terms of having everything installed, so I can just hit Control-Shift-B to build it, all that will work right from the beginning. So if you've ever been in a project where you get in, you have to get the tools installed, you don't really know how to build it, any of that kind of stuff. With my project, you would just hit comma, hit Control-Shift-B. Congratulations, you now have a built version of Module Fast available right here. So that's really handy. And we can sort of show here, and then you can also run the tests. And you can verify all the tests work the same way they do for you. And so then there's certain things here that you can do. You can even test it interactively. So I can go ahead and import the module. And just to show you here, once the module's built, you see this is a binary module. So this is using a lot of C# stuff under the hood to make it fast, as well as add in some nice little format things. And then I can take something like, here's for instance, a 1 million row Excel file. And I can do workbook. And I can test it right away. And so without having to do much and test on the latest version, be able to go through, test it, make sure it works. It's like, okay, great, this is importing. Should take about 15 seconds. I don't know how fast it's going to be in this particular name spot here. But this is a way to, import rows really, really fast, import applications really, really fast, and be able to do that and test and see that that all works right. Okay, make sure that this works. See if even faster way of if you only select the first 100, that it only grabs those and does it really fast. Great. All that stuff I can test, interact, do. So there's a way that you have for building and designing both PowerShell applications or not PowerShell applications using dev containers. And then beyond that, building your own containers to then run applications in a secure, contained, and isolated way so that they're reliable but proven and effective. So thanks very much. And I'll go ahead and come back to the questions here. So can you set up a dev container for persisting data? Yes. So as I mentioned there with that, you have that named volume part that I showed. You can set up named volumes for anything. So you can define in your dev container spec, like there's a certain path that you want to be persisted. And so on that, you could save a NoSQL database. You could save anything that you want. And whenever you reload your container, that named volume will persist until you go into pod manner, et cetera, and delete it. So right now, like I'm persisting my GitHub state. So when I check out and I have that saved, it's all saved here in this container. If I take this and I delete it, then the next time I run this container, it's going to be gone and it's going to be back to the original version. But I have that there. So you can have dev containers. I mean, if you want to have that so that you have like a SQL server that you fill in a bunch of phony data, you can reload and have it stay persisted there. And as you make changes to it and reload it, that persists. You can even with dev containers specify a Docker Compose file, which lets you specify what your base container is, but then also a bunch of sidecar containers. So if you have a container that runs Microsoft SQL or MySQL and you want to use that as part of your development, you can run it. And then that port is available to you, like if it runs on port 2601, you can access it there and you have all of that runnable. So yeah, so that's how you can persist that. In terms of running the container from Azure Automation, it is possible to do in Azure Automation. I just kind of mentioned it as a passing thing. It's not generally recommended, I would say. The best place to run containers are Azure Functions has a way to run containers that I highly recommend. Azure Functions has a way to package the Functions runtime into a container. So if you already have an Azure Functions PowerShell that you're already running, you can take that and go ahead and package it as a container. So if you've already written it, use bindings and all that kind of stuff, you can take it and then throw it into a Kubernetes or anything like that and run it in a container environment, which is really cool. Then there are ways to run containers natively. There's Azure Container Instances, Azure Container Apps, there's Kubernetes or Azure Container Services. And I keep saying Azure, but all this works on Amazon, that works on Google. It works on your on-premise Kubernetes system. It works anywhere containers run. I did a presentation at PowerShell Summit called The Many Ways to Run PowerShell in Azure. When the recordings go up, I highly recommend you look that up. So for the next question, the tip about the comma versus the period in GitHub. So in GitHub, there's two things. There's a thing called VS Code for the web. So I'm going to hit period. And this is where you notice it says web editor. And you also get github.dev or vscode.dev. So this is the thing that you has been advertised a whole lot about, like, oh, wow, look at this. It's VS Code in your browser. And it is. But the thing about this is that this is actually literally running in your browser. Like, it's literally running in the WebAssembly engine of your browser on your local computer. So if you try to, you'll notice here, it'll say you can create a terminal by continuing environment to run code. But this doesn't have any way to run PowerShell or run any kind of command line application because it's not a virtual machine. It's literally a worker in your browser running locally on your desktop. So when you do this, it's a little bit limited, but it's fast. And it's great for things like documentation. It's great for things like editing READMEs. It's great for things like doing anything that doesn't require any of that kind of backend stuff. So like you still get semantic highlighting from the TextMate in PowerShell, even though you can't get all the fancy IntelliSense. So it's still great for a lot of those purposes. And it even supports Copilot too. But the thing is that it's not code spaces. Now this is free forever. But if I go back to my repository here again. So instead, if you hit comma is basically a shortcut for going here to code and choosing start, doing plus on the code spaces, creating a new code space, resuming a code space, etc. You'll see down here, code space usage on this repository is paid for Justin Grote. If it's a public repository, then you get 80 core hours, it's either 60 or 80 core hours for free. And then that's, if you have a 2-core virtual machine, then you get like 30 hours total. If you have a 4-core virtual machine, you get 15 hours total. Any combination of that you use, you get that much per month to use, which is more than enough for most people to do as you need. And then if you need more, you can either pay for more in code spaces, or you can just run the containers locally, as I showed, running locally as well. So yeah, and I'm not sure about Azure DevOps, but I do believe period works in VS Code for the web. That opens the vscode.dev. But there isn't a code spaces for Azure DevOps in the sense that you can't hit comma. However, you can use code spaces to open an Azure DevOps repository. So you can start a code space or start a dev container and then check out your Azure DevOps repository just the same way you would check out any other Git repository and work on it. And you can also define a dev container in your Azure DevOps repository. And when somebody opens it in their local VS Code, they'll get that little reopen in dev container thing and get it so that it runs in a dev container on their local machine. Thanks, everybody. And I'll open up for any further questions. Otherwise, that's PowerShell containers for Docker.